The same bomb, the same nuclear energy, but four completely different scenarios of total destruction. Welcome to the simulation world, a digital laboratory where the laws of physics determine the fate of civilization. Today we are conducting an experiment that no one would dare to execute in reality on such a massive scale. We will take a standard 1 megaton warhead and detonate it in 4 extreme environments. From fire raining down from the sky to a devastating tsunami underwater to a silent death in deep space. Many people believe a nuclear bomb always looks the same. That is a dangerous and common misconception. The environment changes everything: air density, water pressure, or the geological structure of the Earth. We will observe how kinetic energy, thermal radiation, and fallout behave in each of the test zones. Our crash test dummies, equipped with advanced sensors, will show us exactly what would happen to the human body. We begin by preparing Zone A, a vast metropolis that is about to cease to exist in a matter of seconds. Here we see a perfect city simulation, built of concrete and glass, awaiting its final sentence. In the first scenario, we will test what intuitively seems like the most destructive approach: the ground burst detonation. The bomb is positioned directly on the asphalt in the city center. The clock counts down the final seconds. Please pay close attention to the shockwave behavior near the ground. 3, 2, 1. Initiation of the chain reaction within the plutonium core. In a fraction of a second, a fireball forms, instantly consuming everything within a radius of several hundred meters. Because the explosion occurred on the ground, the energy has nowhere to go and digs a gigantic crater into the Earth. Thousands of tons of soil, concrete, and steel are thrown into the air, creating a dark, dirty cloud. This is what we call radioactive fallout. It is the most deadly after effect of a ground-based explosion. The shockwave expands radially, but it meets the resistance of buildings, quickly losing its kinetic energy. Structures near the center are wiped from the face of the Earth, but those further away remain strangely intact. The ground absorbed a significant portion of the blast energy. This is a waste of the bomb's destructive potential. However, the contamination is extreme. This dust will settle over hundreds of kilometers, killing everything alive. Now, let us reset our simulation. We will rebuild the city and attempt something far worse. This time, the bomb will be detonated in the air at an altitude of 2 kilometers above the target. This is the Airburst, a tactic used in Hiroshima designed specifically to maximize widespread destruction. Attention! Detonation! Watch carefully as the fireball does not touch the ground directly. The shockwave hits the ground and bounces off it, chasing the primary wave outward. When these two waves merge, they create a phenomenon called the Mach stem, possessing double the destructive force. This vertical wall of compressed air moves horizontally, shearing buildings like a lawnmower cutting grass. Look at the dummies inside the skyscrapers. They are not burned, they are torn apart by the sudden pressure change. Glass from the windows turns into projectiles, traveling at the speed of sound through the office interiors. The radius of destruction here is twice as large as the ground burst. The city is effectively dead. There is no massive crater here, and not as much dirty fallout, just the pure, raw force of the blast. The airburst is the most efficient method for destroying infrastructure and the population over a wide area. Let us now move to Zone C. We will descend deep beneath the surface of the Earth. Here we test a scenario designed to hide the explosion from the world or to destroy deep bunkers. The bomb is located 1 kilometer underground, surrounded by solid granite rock and layers of clay. When detonation occurs, we see no flash. All the energy is converted into intense heat and vibration. In a fraction of a second, the rock around the bomb vaporizes, creating a gigantic hollow cavern. The walls of this cave melt, turning into artificial magma that drips down to the bottom of the chamber. On the surface, this is felt as a massive earthquake with a magnitude of 7 on the Richter scale. Moments later, the ground collapses inward, creating a subsidence crater, but without the mushroom cloud. This is exactly how superpowers tested their arsenals without violating atmospheric test ban treaties. However, underground pressure is so immense that the rock can crack, releasing radioactive gas upwards. We see fractures spreading toward the surface here. If they reach the groundwater, the contamination will be permanent. The underground explosion is a battle between pressure and gravity, locked within a stone coffin. We now leave the suffocating underground and travel to Zone B, to the open ocean. Water is 800 times denser than air. This means it transmits the shockwave much more efficiently. Our target is a fleet of old warships. The bomb is suspended 200 meters below the water's surface. Detonation. The first thing to form is a bubble of hot gas, glowing with a ghostly light underwater. The shockwave moves through the water like a hydraulic hammer, striking the hulls of the ships. The steel hulls of the submarines are crushed in the blink of an eye, crumpling like aluminum cans. The giant gas bubble pulses and rises rapidly toward the surface, displacing massive amounts of water. On the surface, we see a dome suddenly rising, which then bursts, creating a water column miles high. But the worst is yet to come. From the base of this column, the so-called base surge spreads outward. It is a dense mist consisting of irradiated water and steam, which swallows the entire fleet. Every ship that did not sink from the shockwave is now bathed in a deadly radioactive rain. The seawater becomes a radioactive poison that cannot be washed off the decks. The underwater explosion is the most insidious, combining hydraulic force with extreme contamination. Now it is time for the final frontier, Zone D, space, low Earth orbit. There is no air in space, therefore there is no shockwave, no sound, and no mushroom cloud. The bomb explodes in total silence, but the visual and electromagnetic effects are absolutely terrifying. The fireball is perfectly spherical, expanding instantly, unhindered by any atmosphere. The main killer here is not the blast, but the intense X-ray and gamma radiation. This radiation hits our test satellites, frying their electronics in a matter of nanoseconds. An electromagnetic pulse, or EMP, is created, covering thousands of kilometers in its range. If this were happening for real, power grids on the ground beneath the blast would cease to function. Charged particles are trapped by the Earth's magnetic field, creating artificial auroras. Beautiful, colorful lights in the sky that herald the collapse of technological civilization. This is the paradox of a space explosion, visually the most beautiful, yet fatal to our technology. Let us now compare these 4 scenarios side by side to understand the scale of the phenomenon. On the ground, we have local destruction and dirt. In the air, we have the maximum shockwave range. Underground, we have seismic tremors. Underwater, hydraulic contamination. And in space, the EMP. Nuclear physics is not one-dimensional. It is a chameleon that adapts its destructive form to the environment. Our test dummies in all zones were destroyed, but each in a completely different way. Some were vaporized, others were crushed, and still others were cooked by pure radiation. Let us take a closer look at the details of destruction in slow motion, frame by frame. In the urban zone, we see the pressure wave forcing its way into the smallest corners of the streets. Cars are lifted into the air like toys, and steel structures bend like plasticine. In the underwater zone, we see cavitation. The water boils from the sudden pressure drop behind the wave. This phenomenon further destroys propellers and delicate elements of the ship's plating. In space, the lack of atmosphere means heat is not transferred by convection, but by radiation. This means if you are in the shadow, you might live, but in the light of the blast, you burn instantly. This simulation shows us how fragile matter is when facing the unleashed energy of the atom. Let us return to Zone A to analyze the long-term thermal effects, specifically the fires. After the shockwave passes, the superheated air ignites everything flammable. A firestorm is created, sucking oxygen from the area, suffocating those who survived in shelters. It was the firestorm, not the blast itself, that caused most of the casualties in historical raids. In our simulation, we see the entire city turning into one giant blast furnace. Conversely, underwater, the temperature is quickly absorbed, but contamination remains for years. Ocean currents will carry radioactive isotopes across the globe, affecting the entire food chain. It is an invisible killer that works much slower than a shockwave, but just as effectively. In the underground zone, molten rock takes months to cool, trapping radiation in a glassy mass. These are geological scars that will remain in the Earth's crust for millions of years as proof of our era. The simulation is coming to an end. Data has been collected and analyzed by our system. We see graphs that clearly indicate there is no safe place near Ground Zero. Whether you are standing on the ground, swimming in the sea, or orbiting in space, physics knows no mercy, no politics, and no morality. It only reacts to stimuli. This megaton of energy we unleashed digitally is just a fraction of the world's stored arsenals. Now imagine that these four scenarios are happening simultaneously in thousands of places. This is no longer science. This is a doomsday scenario that we hope remains only inside a computer. Thank you for participating in this experiment. Your observations are crucial to understanding the threat. We now see the final shots from a drone flying over the ruins of our virtual metropolis. The silence that falls after the explosion is louder than the blast itself. It is the silence of non-existence. In the distance, smoking craters and remnants of structures that were once the pride of engineering remain. Even in the digital world, these images evoke a primal fear of the power of nature we have harnessed. But knowledge is power. Understanding the mechanisms of destruction allows us to better protect the future. That is why we continue our simulations, testing the limits of materials and structural endurance. In the next stages of research, we will focus on defense systems and possibilities for survival. But for today, this is the end of our demonstration of force. The machines will be turned off, the world reset. Remember that what you saw was pure mathematics dressed in photorealistic graphics. Reality would be far more chaotic and terrifying than any render could ever be. Let us look one last time at the space zone. Those beautiful auroras are deceptive and dangerous. They remind us that even in a vacuum, our actions have their consequences. Electrons continue to dance in the magnetic field, creating a light show for no one. In the depths of the ocean, the water slowly returns to equilibrium, filling the void left by the gas bubble. Nature always strives for balance, even after such a violent disturbance as a nuclear explosion. Underground, the magma hardens, creating a new geological layer that future generations will discover. And in the city, the dust slowly settles, covering the ruins with a gray shroud of oblivion. Each zone told us a different story about the end, but the moral remains the same. Nuclear energy is a double-edged sword. It can give light, or it can bring eternal darkness. As architects of this virtual world, we have the luxury of pressing the restart button. In real life, there is no such option. That is why these simulations are such an important warning. Analyzing the data, we see that the lowest chance of survival was in the Airburst zone. This is a valuable lesson in military strategy, showing how critical the altitude of detonation is. On the other hand, the underground zone proved safest for the surrounding environment on the surface. This suggests that in the event of an attack, deep bunkers are the only real chance for survival. Our dummies in the deep bunkers survived the tremors, although their fate would be uncertain. We are slowly finishing our journey through these 4 circles of nuclear hell. We hope this visualization helped you understand the physics behind these phenomena. It was not magic, nor action movie special effects. It was a raw, scientific simulation. Every pixel on the screen was calculated according to fluid dynamics and thermodynamic equations. Thanks to the engineers and programmers who created this physics engine. Now, as the smoke clears and the screens go dark, we leave you with these images to ponder. Will the technology we created ultimately save us or lead to our doom? The answer to that question is not in the program code, but in human decisions. We return to the starting point, to the black void where it all began. The bomb is whole again, intact, waiting dormant for the next command. It is a cycle that we can repeat endlessly in our laboratory. If you enjoyed this analysis, let us know what other scenarios you want to see. Perhaps an asteroid collision? Or maybe a supernova explosion near our system? Our graphics engine is ready for any challenge you put before it. Remember to subscribe to our channel so you do not miss future experiments. Physics is fascinating, sometimes terrifying, but always worth knowing and understanding. Thank you for watching, and see you in the next episode of our simulator. Safety is an illusion, but knowledge is the only true shield. This was a report from Ground Zero. End of data transmission. System closing all active processes, disconnecting from simulation server.
See you on the other side of the screen.